Welcome. Okay, so today we are going to be learning about sets. Okay, so it's a very good topic in algebra. Okay, so our lesson objectives are by the end of this lesson, you're supposed to be able to understand what are sets and be able to simplify simple sets and simplify them. Okay, then learn how to add, subtract, and multiply sets. Then you will be able to learn how to rationalize the denominator when you are given as sets as fractions. Okay, so this is what we are going to focus on. First, let's understand what is a set. Okay, a set is an irrational number that cannot be simplified to remove the square root, the cube root, or any root. Okay, so in other words, it's a root that does not result in a whole number or a fraction. Okay, so let's say you are given a root of a number, let's say root of a. If you cannot simplify this root of a to give a whole number or a fraction, it becomes a irrational number. Okay, it's a set. Okay, so in simple terms, you can say a set is an irrational number with a root, a square root, or a cube root. Okay, so we are going to be dealing with the square roots as in O level. Okay, so this means that these numbers like root 2, they cannot be simplified to give a whole number or a fraction. Root 3 and root 5 and root 7. Okay, they go on and on. Okay, they cannot be simplified to give a fraction or a whole number. Okay, so they become sets. Okay, so we are going to be dealing with this and know how do we deal with them, how do we multiply them, how do we add them. Let's start by simplifying sets. Okay, this is a basic topic in sets. Okay, so let's say you are given a number like root uh, 40. Okay, you are given this number. You know that 40 is not a perfect square. In other terms, 40 does not have a root. Okay, but you're asked to simplify it. Okay, simplifying this number is making sure you get the smallest set possible. Okay, so this is a big set. Okay, you want to get a smallest set as possible. Okay, the smallest set can be from root 2, root 3, root 5, root 7, root 10. Okay, these are the smallest sets. Okay, so we want to simplify this. Okay, so to do this, you find a factor of 40, which is a perfect square. Okay, the first thing is to find the factor of 40, which is a perfect square. Okay, okay, next, you just have to express 40 as a product of that perfect square and another number. Okay, let's say in this case, you can see that 40 is the factor of 40, which is a perfect square, is 4. Okay, so we can now say 4 times 10. Okay, this is the process of simplification. After doing this, now we can separate this to become root 4 times root 10. Okay, after simplifying this, you can now know that root 4 is equals to 2 times root 10. Okay, so your answer becomes 2 root 10. Okay, this is the process of simplifying it. Okay, in other terms, you can say you can be given another number. Let's say you are given a root 50. Okay, you know that there is no root for 50. Okay, so this means that you should get a set from this. Okay, so now the first thing is to find a factor of 50, which is a perfect square. In other terms, you should find the biggest factor of 50, which is a perfect square. In this case, we have 25. Okay, so this means that if you say 25 times 2, you get 50. Okay, so you can say 25 times 2. Okay, so now you split them. It becomes root 25 times root 2. Okay, now you can now know the root of 25 is 5. Okay, so your answer becomes 5 times root 2. Okay, which becomes 5 root 2. Okay, so this is the process of simplifying sets. Okay, the first thing is you just have to find the factor, which is a perfect square. Then you have to separate it, and then you have to simplify. Okay, next, our concept is adding and subtracting sets. Okay, so let's learn about adding and subtracting sets. Okay, these are the same. Adding and subtracting is just the same. When you understand maths very good, you know that adding and subtracting, they're just the same. Okay, so the only thing is you cannot add, you can only add and subtract sets that are like sets. Okay, meaning that they have to be this, they have to have the same set part. Okay, so this means that a number have to have the same set part. Okay, so let's say you're given a set number root 5 and you ask to add it with 2 root 5. Okay, the set part is the same. Okay, the set part is the part which has a root which we cannot solve. Okay, that's the set part. Okay, so when the set part is the same like this, here root 5 and root 5, you can easily add this. Okay, so this one you just have to add like you are adding x. Okay, so you say 2x plus x, it becomes 3x. Okay, in this case we have root 5 plus 2 root 5. Okay, this means that you can now simply say 3 root 5. Okay, this is the simple way of adding. Okay, now let's talk about subtraction. Let's say you have 5 root 2 subtract 3 root 2. Okay, it's easy as that. You have to make sure that there is this said part is the same. This said part is the same. Okay, so now after you found out it's the same, you simply have to multiply to subtract the whole numbers. Okay, in this case it's 5 minus 3. Okay, so after 5 minus 3 you can get it becomes 2 root 2. Okay, this is your answer. Okay, when you are given a set, like let's say you're given 3 root 5 and you're asked to add with 2 root 7. Okay, there is nothing you can do here. It's just a said number. It's just a rational number. There is nothing you can do. There's no need to solve it. It's already a said number. Okay, when this said part is different, there is nothing you can do. Okay, so you have learned that you can subtract only when they are like sets, meaning that they have the same said part. Okay, let's go on and see how do we multiply them. Now let's talk about multiplying sets. Okay, so to multiply sets, we just have to use a certain rule. Okay, let me write the rule. Okay, so you are given a root A is multiplied by another root B. Okay, these are two sets. Let's assume they are all sets. Okay, so the rule is you just have to take this root and say A multiplied by B. Okay, so after you get that, it becomes root AB. Okay, just have to do this. This is the same rule you use to multiply sets. Okay, let me do a practical example. Let's say you're given a set number root 3 is being multiplied by another set number root 2. Okay, so the easy way you do, you just have to put your root here, then you say 3 times 2. Okay, so it becomes root 6. Okay, this is the easy way you multiply it. Okay, that's the easy when you are given two sets. Let's say another example, you are given root 5 is being multiplied by root 7. Okay, you just have to take your root here, then you say 5 times 7. Okay, so your answer becomes root 35. Okay, as easy as that. Okay, this is the way you multiply set numbers. Okay, let's talk about the way you multiply when you are given sets. Let's say you are given a compound set. A compound set is a set where it consists of a real number and a set number. So let's say it's 2 plus root 3 is being multiplied by another set, which is in this case, let's assume it's 2 plus root 5. Okay, so how do you do it? You just multiply the same you do in algebra. You just destroy this one and say 2 multiplied by 2 plus root 5, then say plus root 3 multiplied by 2 plus root 5. Okay, the same you do in algebra. If you have a shorter way to do it in algebra, just do that way and you'll see when you have to change. Okay, now you just have to say 2 times 2 get 4 plus 2 times root 5 becomes 2 root 5. Then here root 3 times 2 becomes 2 root 3. Then here root 3 times root 5. You just have to say root 3 times root 5. Okay, here you get root 15, as I said in the previous multiplication. Now you have to say 4 plus, oh, here you see there are two sets here. They are different. You don't be tempted to add them. Okay, these ones are different. Okay, so they just you just leave them like this. So it becomes 2 root 5 plus 2 root 3. Then here it becomes plus root 15. Okay, so this will be your answer. Okay, so please do not add these ones because they have a different set part. This means that they cannot add each other. Okay, so this becomes the answer. Okay, but if it was the same set part here, you can simply add. Okay, now let's talk about the most important part of this set topic. It's rationalizing the denominator. Okay, it's a bit tricky, but it's very easy. Okay, so when you are given a set number, a fraction with a set number, let's say you are given a fraction 1 over root 2. Okay, this fraction is very common because it is used a lot. Okay, so here it's not good to leave the denominator as a set number. Okay, so we have to rationalize it. Okay, so how do we do that? When you are given a fraction like this is a simple fraction. You just have to multiply at the bottom with root 2 and multiply at the top with root 2. Okay, it's easy as that. Okay, here you can see that if you multiply 1 and root 2, it becomes root 2. Then here, if you multiply root 2 and root 2, it becomes root 2 times 2. Okay, which becomes root 2 over root 4. Okay, we know root 4, so it becomes root 2 over 2. Okay, so this is the steps you take when you are rationalizing the denominator. It's easy, right? We just have to multiply with this root 2 at the bottom and then the top. Okay, let's say you're given another set. Let's say it's a 3 over root 5. Okay, you are being asked to rationalize it. you just have to take this bottom part and multiply it root 5, then multiply again with root 5. Okay, on top it becomes 3 root 5, right? Then on the bottom, when you see the numbers are the same, they will just bring us this number. Okay, let's try it. You just have to get 5 times 5. Okay, they become 3 root 5, then they become root 25. Okay, after that it becomes root 25 is 5. Okay, so it becomes 3 root 5. Okay, so this will be your answer. Okay, so this is the simplest way you rationalize the denominator. Okay, let's go on to a tougher one. Okay, so let's say you are given two compound sets. Let me say you have let's say you have 3 all there on the top, and you are given 2 plus root 3 at the denominator. You are being asked to rationalize the denominator. You have to rationalize it. How do we do it? Now it's different from this. Now you have to take this set, right? This part, this bottom part, and say 2. Then change the middle sign. Listen to me, right? Change the middle sign. It's plus here, so you have to say it's minus. You have to say it minus here, root 3. Then multiply on top and bottom. Okay, so it becomes multiplying by 3 here, then it becomes multiplying by this one. Okay, so this is the simple way. Okay, now you are saying you just have to change the sign here. In this case, you are not changing anything, you're just multiplying by the denominator. But here you're multiplying by the denominator, but you are changing the middle part. Okay, so now you have to multiply them. Okay, so it becomes on the top, it becomes 3 2 minus root 3, right? Okay, then on the bottom it becomes, you multiply it like the multiplication we did on top. Okay, on the previous chapter, the multiplication, let me do it fast here so that you can save time. So here is 2 times 2, it becomes 4. Then here is 2 times root 3 minus root 3 becomes minus 2 root 3 plus 2 root 3. Okay, you are multiplying this and this. Now you multiply this and this, it becomes root 3 times root 3. Okay, now, the trick is when you see a root is multiplying by itself, root 3 times root 3. Okay, this means that the answer is just 3. You don't have to worry. Like here, you see in this case, root 2 times root 2, the answer becomes 2. Here, root 2, 5 times root 5, it became 5. Okay, so in this case, you just have to multiply, you just have to leave it like 3. Okay, so on top, it becomes 3 times 2, it becomes 6 minus 3 times root 3, it becomes 3 root 3. Okay, then at the bottom it becomes 4, right? Then minus 2 root 3, this you can subtract this because they have the same set part. You can see they have the same set part. Okay, so you just have to say they can subtract each other. 2 root 3 minus 2 root 3, so this answer becomes 0, right? You can check it here, it becomes 0. Okay, now we have 4, then here root 3 times root 3, it becomes plus 3, right? Like I said, root 3 times root 3 is just 3. Okay, so the answer becomes plus 3. Okay, so this means that our answer becomes 6 minus 3 root 3 over 7. Okay, so this will be our answer. You can see now the denominator, there is no set part on the denominator. Okay, so you can now say we have your answer. Okay, let's say you are given another example. Oh, I like to give an example. Okay, in this case, we are given two sets part. Let's say it's 3 plus root 2, and on the bottom is 4 plus 2 root 2. Okay, you just have to follow the same procedure, but here on top you have to multiply with 4 minus 2 root 2. Okay, so mind that you are going to multiply these sets twice, on top and on bottom. Okay, so you just have to multiply like this. Okay, so you just have to follow this step. Now only multiplication left. Okay, so this is the way you rationalize the denominator. Okay, thank you. Please stay in touch.